Hi everybody in Research Methods. This is our new normal, for better or worse. I'm sure you're aware that everything is moving online. So some good news and some bad news. Some bad news, you are going to have to keep up with all the material and perhaps teach yourself to a large degree. The good news is I am here to help you. Phone call, we can FaceTime, we can email, Canvas message, whatever, and make this work. I'm not going to leave you hanging, I promise. We'll get through this together. So let me know what I can do to help you each week. I am going to be posting videos that go along with what would be each class period or each section in the reading packet, depending on the topic. And here's some good news. You still are responsible for the same material, exams and labs and assignments and the paper. Yeah, the paper. But you get to do it all with open book, open note, and everything. That's including the exams. So let me know how I can help. So let's get started with today's stuff. We're almost ready for an exam, by the way. If we were in class, the exam would have been March 24th, but obviously that's not going to happen. We have to do 2 more sections, and then you can take it on your own time. The only deadline will be the end of the semester. Everything has to be finished. So, section 11, the null hypothesis, rejecting the null, and the charts that go with it. First of all, in research methods and in all studies, psychology and otherwise, all social sciences and even the hard sciences, you start with the assumption of the null hypothesis. This is a little tricky. You assume that things are no different, that they're not correlated, that they're not related, that there was no change, that one group is no different than the other group. That's the null. But in most research studies, what your goal is would be to disprove the null. Usually you want there to be a significant difference. You want there to be a relationship. That's not always true though. Let's say you make a generic drug that's supposed to be just as good as Prozac. I would say you want there to be no significant difference. You want to retain the null, H0. I would suggest following along in the reading packet with me, by the way. That would be the smartest thing to do. Most studies, however, you want to reject the null hypothesis. You want there to be significance. That is often known as the alternate hypothesis, H1. But we're going to talk more about the null than anything today. So, first of all, you have to decide how certain you want to be. Unless you're testing your entire population, all people, all students, whatever, that doesn't usually happen. Usually there's an area of uncertainty. So therefore, how certain do you want to be? 95% sure, 90% sure, 99% sure? Well, in psychology, we often use the criteria 0.05. That's known as an alpha level. You can call it the critical region of your curve, but it's easier to understand by saying, I want to be 95% sure, I want to leave no more than 5% room for error, the alpha level. Now, if that's not confusing enough, when you enter your data, you're going to find what's called a p-value. The p-value is how the data came out, what the results were. So, this does get a little confusing. I wish we were all in class together and I could write it on the board. But as we get through this, it will make more sense. So, you have an alpha level that you set in advance. In psychology, we typically use 0.05. I want to be at least 95% certain and have no more than 5% room for error. That is to reject the null, to say that it is statistically significant. Let's say males versus females, or college students versus high school students. I want to be that certain that my groups are different. Now, what if I do my statistics and group A is high school kids and group B is college students, and my p-value, it tells me, after doing the t-test, is 0.07. What would I say? I just missed. I wanted it to be 0.05 or less. I wanted there to be statistical significance to prove that my intervention is so much better for college students than high school students, or attitudes, or whatever it is I'm studying. So in that case, I just missed. What if my p-value was 0.04? Well then, it is significant. I am more than 95% sure. In that instance, I'm 96% sure. Only 4% room for error. So this is confusing. You might need to watch this video and follow along with the reading packet more than once if it's confusing the first time. Or you can call me, text me, email me, whatever. Canvas message me, we'll make it work. This stuff is confusing. It really is, especially the first time that you are hearing it. So that is how alpha levels work. You set it in advance, usually 0.05 in psychology. But let's backtrack a little. Can you think of any studies where you would want to be more than 95% sure? Maybe 0.99 and then 0.01 would be your alpha level? Perhaps that would be a study of medicine or a life-saving procedure or something like that. You could even require your test to be even more certain than that. 0.001, 0.0001. DNA testing, was that this person's blood at the crime scene? Is that really his baby? You want to be more than just 99% sure. Birth control. Yeah, I know it's embarrassing to talk about, but if you look on the box or the prescription, it will tell you how safe it is. And obviously you want that alpha level to be a low number. You don't want it to just be 85% safe. That would be ridiculous. What about taste testing? Do people like Coke or Pepsi better? Would they prefer blue or red? Maybe your alpha level is only 0.10. Maybe you only need to be 90% sure. But in psychology, we typically use 0.10. That's typically what we use. So, if you look at this 4-square chart on the next page, I know it's a little confusing, but I am just going to hit the highlights, and that's all you need to know for this exam that's coming up. So first of all, you are the experimenter. What if you did your results and you got 0.02 and you only needed 0.05? You're thinking, I'm going to reject the null hypothesis. Group A and Group B are different. But wait a minute, what if you were wrong? What if the actual situation is something different than you had anticipated? So let's go over these 4 real quick here. Actually, just the 2 that you need to know. First of all, a type 1 error is when you had a biased group of people, or perhaps Group A and Group B are both biased groups of people. One is an honors group, one is a group of, a party group of students who don't go to class and they're only there to socialize. I made that up, but still, it's a good example. They would both be biased. You want people to be random as possible. So therefore, if you think you found significance, you rejected H0, but really you should not have found significance. The actual situation was that there was no effect. Then what you have is a type 2 error, when you thought you had significance, but you didn't. So, you're not going to be selling this reading packet back to the bookstore. Why not make yourself some notes in it? Where it says type 1 error, bias group, or maybe bias groups. How does a type 2 error happen? You as the experimenter decided to retain the null hypothesis, the assumption that there is no difference. But what if you later found out that you were wrong? There really is a significant difference. Well, here's what you write for type 2. Samples too small. And when some of you get your results, I can almost guarantee that this will be a problem. That you didn't use enough people, and that's why you didn't find significance. So it would not surprise me at all if people call me, FaceTime me, whatever you want to do, and say, hey Scott, I just ran my data. Look, I got 0.09, I just missed 0.05. And then I'm going to be like, how many people did you use? Oh, I had 7 in one group and 8 in the other. Well, you know what? I'm thinking the samples were too small. If your samples were bigger, you probably would have found more significance. So again, here's really what you need to know on this page. Type 1 errors happen, biased group or biased groups. Type 2 errors happen when you didn't use enough people. Samples too small. Now we're ready for section 12 in your reading packet. This goes right along with section 11, and that's why we would have covered this in one day. Percentages, percentiles, and the normal curve. First thing to know, a percentage sounds like percentile, the words sound the same, and the Webster's Dictionary definitions that I included here don't really help either. It really makes it sound a little too similar. So let's talk about that real quick. Percentage. How much out of 100 did you get? If you got 40 out of 50 on my test, you got an 80%. If you're batting .350, well, you're hitting 35% of the pitches into the field of play and you're not getting out. Regardless of what we're talking about, whether it's sports or academics, percentage is the number that can be divided into 100. Percentile seems the same, but it really is kind of different. Percentile compares you to other people. So if you're in the 80th percentile, that must mean that you're above 80% of people and below 20% of people. If you're in the 95th percentile, well, there's only 5% of people above you. Now, a few things to keep in mind for the exam. One, that would be being a high percentile is not always a good thing. I wouldn't want to be in the high percentile for my cholesterol rate, nor would I want to be in how much debt I have, how much money I owe to other people or companies like credit cards. I would want to have a low percentile. However, most of the time you want to have a high percentile. You want to be smart, you want to have money, you want to be educated. Most of the time you want to be above other people. Here's another thing to note. You cannot be in the 0th percentile or the 100th percentile. 0th percentile means you are lower than everybody. How could that be? You're part of the group. And you cannot be in the 100th percentile either. How could that be? You're part of the group we're talking about. So you could be in the 0.99999 percentile. That means you're higher up than almost everybody, but you can't be higher than yourself. That doesn't even make sense, huh? So that's what I want you to know, percentage and percentile. You might have a job one day, perhaps you have already, where you're competing with coworkers and they tell you your percentile. If you ever took the SAT or the ACT, you probably don't know exactly how many questions you got right and wrong. Instead, you know how you compare to other people. All of those are percentile. But in my class, percentage is what's important. You need to know how many points you got. You're not competing with other people to be higher or lower than them. So that is something that you want to make sure you understand for the exam. And that is on the one and only page of content for section 12. Now, the opposite side of the page is really just a pretty picture. It's more of a description of how this plays out in real life. For example, the first one shows you IQ scores and standard deviation. What would put you higher than other people? 1 standard deviation and 2 and 3. What about below average? 1, 2, and 3. It shows you that by percentile. It also shows you by stanine. When you were little in an elementary school, they often use that to test people. Which of the 9 categories would you fit into? What about splitting it up by tens? 10, 20, 30? I really wouldn't worry about specifics. I would just worry about understanding the difference between percentage and percentile. Well, that's it for today. We will have more next time. Take care and keep in touch.